All right, let's jump right into today's explainer. We're going to uncover an absolute life hack of a math concept that scientists use to measure literally everything, from gigantic galaxies all the way down to invisible atoms. You know, when we look at the world around us, we're constantly confronted by extremes. We have the mind-boggling scale of the cosmos way up above us, and then the incredibly tiny building blocks of life right here on Earth. To give you an idea of the extremes we're dealing with, there are actually more stars in the observable universe than there are grains of sand on all the beaches on planet Earth combined. I mean, just let that sink in for a second. We're talking about numbers so insanely large that they completely break our standard way of communicating. So today, we're going to learn exactly how scientists and engineers handle these immense extremes without getting totally lost in a sea of zeros. But hey, before we crunch any numbers, take a second to just think about the sheer awe of the universe. Psalm 147, verse 4 says, "He determines the number of the stars and calls them each by name." Even the absolute biggest numbers in space, numbers that seem completely infinite and unmanageable to our human minds, they're fully known, measured, and named by God. It's a beautifully humbling thought, isn't it? But here's the exciting part for us as learners. Today, we are learning the exact mathematical tool we need to step up and begin describing, quantifying, and comprehending those immense scales ourselves. We're literally learning the language of the universe. So, here's our flight plan for today. We'll hit the language of the universe, then decode scientific notation, go from macro to micro, test your knowledge, and finally wrap up with education with morality. Let's do this.
Starting off with Section 1, Language of the Universe.
Picture this. You're trying to write out the distance from the Sun to the Earth over and over again. That distance is roughly 93 million miles. To put that into perspective, light, which travels at an astonishing 186,000 miles per second, still takes over 8 minutes to cross that gap. Now imagine you're a NASA engineer plotting a highly sensitive trajectory to Mars. You have to write that 93 million out, or punch it into a computer simulation, dozens and dozens of times a day alongside other massive planetary distances. One slip of the pen, one fatigued keystroke missing a single zero, and boom, your multi-billion-dollar satellite misses its target completely and just drifts off into the void of space. In the real world of high-stakes science, standard numbers just stop working efficiently. Now let's flip it and look at the exact opposite extreme. The thickness of a single human hair is about 0.00007 meters. It's incredibly thin, yet to a biologist studying cellular structures or tiny viruses under an electron microscope, even a single strand of hair might seem huge by comparison. Keeping track of exactly how many zeros come before the 7 is tedious, time-consuming, and honestly, incredibly prone to error. If a researcher accidentally writes 3 zeros instead of 4, they've suddenly increased the size of what they are studying by a factor of 10. That could completely ruin a medical formula or a chemical reaction. So whether you're dealing with the vastness of astronomy or the microscopic realm of biology, standard form is simply a liability.
So you can see the problem, right? Trying to comprehend the size of a virus, the mass of a planet, or the speed of light is just completely overwhelming without a better system. Scientists, engineers, and mathematicians across the globe absolutely require a universal language to share data precisely and efficiently. We need a way to compress these bulky, error-prone numbers into something sleek, readable, and perfectly accurate every single time. We need a system that crosses language barriers and disciplines, allowing an astrophysicist in Japan to instantly communicate with a chemist in Brazil without any confusion whatsoever.
Which brings us right to Section 2, Decoding Scientific Notation. This right here is the key. Scientific notation is a mathematical format that allows us to write extremely large or incredibly tiny numbers using powers of 10. Instead of focusing on counting zeros, we use exponents to do the heavy lifting for us. Because our entire numbering system is based on 10, multiplying or dividing by 10 simply shifts the decimal point left or right. Scientific notation totally takes advantage of this mathematical reality. It's a foundational skill, so foundational that it's embedded in core educational standards like TEKS 8.1a, but practically speaking, it's the language of discovery. It's how we neatly organize the entire universe onto a single sheet of paper.
And this brilliantly illustrates the aha moment. Compare standard form to scientific notation. Notice how much cleaner the distance from Earth to Jupiter looks in scientific notation. Instead of writing out 483 million miles, we just write 4.83 times 10 to the 8th power. Think of that little 8 as a set of instructions. It's telling us to take the decimal point after the 4 and physically move it 8 spaces to the right, filling in any empty spaces with zeros.
Moving it 2 spaces gets us to 483, and we have 6 more space to go, which means adding 6 zeros. It's compact, it's beautiful, and it immediately tells another scientist exactly the scale of the number they are looking at without having to count a single zero.
Moving right along to Section 3, from macro to micro.
What's really fascinating here is how easily we can compare totally different scales using this one format. We already talked about Jupiter, but think about the diameter of a red blood cell. In standard form, it's a messy, confusing decimal. But in scientific notation, it's an elegant 7 times 10 to the negative 6th power meters. The moment a biologist sees a negative exponent, like that negative 6, their brain instantly registers microscopic, no zero counting required. It's basically a scientific cheat code. And then look at the mass of the Earth, 5.97 times 10 to the 24th power kilograms. Trying to write that in standard form would be a 5, a 9, a 7, and 22 zeros. Scientific notation makes the impossible to read instantly readable.
All right, time for Section 4, Test Your Knowledge.
Go ahead and grab your notebooks, maybe take a quick screenshot of these, because I want you to tackle 4 practice problems. Number 1, try converting the massive distance to Neptune, 4.5 billion kilometers, into scientific notation. Number 2, do the exact same thing for the tiny width of a grain of sand, which is 0.0003 meters. For number 3, we're going to reverse engineer it. Take 1.8 times 10 to the 6th power and convert it back into standard form. Remember those instructions for moving the decimal. And finally, number 4, flex your creative muscles and write your very own word problem involving space or science. This is how you truly master the language of the universe, by actually speaking it and applying it yourself. And for your 5th homework prompt, here's a critical thinking question. Is the Earth at 5.97 times 10 to the 24th kilograms heavier than the Moon, which is 7.35 times 10 to the 22nd kilograms? Notice how you don't even need to know what those huge numbers fully look like when they're written out with all their zeros. If you just look at the exponents, the 24 versus the 22, you instantly know the Earth has 2 extra powers of 10. That means it's roughly 100 times more massive than the Moon. You didn't have to crunch massive strings of numbers. The exponents literally did the work for you. That right there is the sheer power and efficiency of scientific notation. Finally, let's head into Section 5, Education with Morality. We purposefully intertwine biblical morality with education in this series for one very specific reason. Education without morality is gonna hurt. History is totally full of brilliant minds who developed incredible technology and completely mastered mathematics, but used their knowledge for destruction rather than creation, simply because they lacked a solid moral foundation. Think about the splitting of the atom. The complex math and science behind it can be used to generate clean, sustainable energy for millions, or it can be used to create devastating weapons. What is the point of being highly educated, of understanding complex math like scientific notation, of being smart and capable if you make choices that end up harming yourself and society? Knowledge is a tool, for sure, but your morality determines how that tool is swung.
And that brings us to a really powerful truth from Romans chapter 8, verses 6 and 7. It promises peace of mind to everyone who keeps their mind spiritual. This is the core experience we want for you as you engage with this content. True peace of mind comes to those who keep their focus grounded in a spiritual framework, guiding how we actually use our newfound intelligence. When we combine the mathematical laws of the universe with the moral laws of the Creator, we become not just smarter, but wiser. We gain the ability to navigate really complex problems with both intellect and integrity.
As we wrap up this explainer, I want to leave you with one final provocative thought to chew on today. How will you use your education and mathematical knowledge to make good, moral choices in this vast universe? You now have the fundamental tools to measure the brightest stars and the microscopic building blocks of life. The language of the universe is now yours to speak, so what will you build with that knowledge? Thank you so much for learning with me today. Keep exploring and keep choosing wisely.